evening and welcome viewers. Today we are going to introduce you with a new term, that is Introduction to Spectroscopy. So in this lecture we will see what is spectroscopy, how it helps, and then where are the uses of this spectroscopy. At the end of the lecture you will be able to give the answer of certain questions like what are the units of measurements of spectral lines, what is spectrometer, how spectroscopy works, and what is the spectra, what do you mean by spectrum. So etc. All these terms, at the end of the lecture you will be able to find the answer of these terms. So let us start with our basic questions that arises when we study spectroscopy. So the first question arises, what is it? What is spectroscopy? So then second question arises, where it helps, and the third question arises, how, then how it helps. So let us first try to answer these questions step by step. So first basic question is, what is spectroscopy? So let me first write the definition and after that I will try to explain it. So spectroscopy, you know that spectroscopy is the study of interaction of radiations with matter. What is spectroscopy? Spectroscopy is the study of interaction of radiations with matter. So the radiation including the whole spectrum of electromagnetic radiation, ranging from gamma, UV, visible, etc. whole the spectrum of electromagnetic radiations. So these radiation interacts with matter. So interact means what? Interact, there are two terms. Interact, what happens? Suppose we have a matter, and now let us consider we throw some light or radiations on it, irradiate this matter with radiations. Then what will happen? How this matter will respond to these radiations. It means the interaction in between radiations and matters. So there could be two possibility majorly. First one is the matter emits these radiation. Second is the matter absorbs these radiation. So interaction means the matter emission of radiation or absorption of radiations. So there are two possibilities in interaction, either emission or absorption. Now let us see what are the nature of this interaction, what we will extract from emission and absorption. So this is nature. What is the nature of spectra? Spectra is the record what we will get after. Spectra means, suppose these radiations interact with this element, then here we will set a detector, then what we will detect. So that detection, that what we record on a paper, on a sheet, or whatever we used. So what we used is termed as spectra. The spectra is just a plural for spectrum. The plural word is used as spectra. So what is the nature of this spectra? When these radiation interact with matter, then we find some types of patterns. These patterns could be of any type. So we will see this spectrum. What is the nature of this spectrum? So this spectrum, in nature the spectrum is unique. Unique means what? Unique means if you have particular type of matter, suppose we have iron, then what we will detect on a detector would be unique for iron. If means suppose for iron we have a certain type of spectra, and suppose for copper we also have a certain type of spectra, then unique means the nature of this spectra will never resemble with any substance's spectra. it means this is unique. For iron, it will always have this type of shape and will never resemble with any other material. It is as simple as we have our fingerprint. So our fingerprint is unique. Nobody in this universe have fingerprint like us, like each and everyone. So everyone has a unique fingerprint, and the retina of our eyes, this is also unique, and we have a unique identification number, Aadhaar card. So just like Aadhaar card, this what we get from Aadhaar card, we get from Aadhaar card the personal information of that individual being. So similarly from and by analyzing the spectrum of any substance, we can get the whole information about that matter or that substance. So this is the nature of the spectrum of any atom or molecule. Next we will see where it helps. So I think you get the answer of this question. What is spectroscopy? Spectroscopy is the study of interaction of radiations with matter, and interaction could be in two ways: either emit or absorb the radiations, and the nature of that particular spectra is unique. And now we will see where this term is used, where the branch spectroscopy and what this spectra helps, in which information we will use this spectra. So let us think, I should erase this too. Next we will find the answer of where the spectroscopy is used. First, by analyzing the spectra of any element or atom, we can find the interior arrangement of atoms. Arrangement of atoms means what? Means its electronic configuration. Electronic configuration we can find by analyzing the spectra of that particular atom. Second, we can find the motion of electron. We can find the motion of electron. Motion of electron means the angular momentum of electron. Angular momentum of electron. And third is we can find the energy of atom. Basically we can find the nature of energy. By analyzing the spectra, we can find the nature of energy. Fourth one is the spin of electron. The concept of electron also as a spin, also found by the spectroscopy. So spin of electron is also found out with the help of spectroscopy. So these are the informations that we extract by analyzing the spectra of any element. So by analyzing the spectra of any element, first we can find the arrangement of atoms, means how the atoms are arranged inside that material. Second, motion of electrons. What is the speed of electron? Means the angular momentum of electron can easily be found out by studying the spectra of that particular element or atom. Second is the energy of atom. So energy of atom, how we will find the energy of atom? So energy of atom is simply means, suppose we have a spectra, and suppose the spectra is in the form of lines, this discrete lines, irregular intensities and irregular spacing in between these lines. Suppose we have this type of spectra for any arbitrary atom. Now by analyzing this spectra, we can say that the element of which this spectra is have discrete energies. We can say that the energy of this element have discreteness, means the energy is not continuous, because the spectra is not continuous. So by studying the spectra, we can find the energies, the nature of energies of any atom. If the spectra is continuous range, then we can easily say the energy of this atom is continuous in nature. The spectra is discrete, means the energy is also discrete, is quantized. So this is the usefulness of studying spectroscopy. Next is how spectroscopy helps. So in it we will see the arrangements and the types of spectroscopy and the units of spectroscopy too. So now let us throw light on the third question, that is how spectroscopy helps. So spectroscopy, how? So there is an instrument used to measure the spectrum. So instrument used is known as spectrometer. You are familiar with it. So in spectrometer there are three basic components. One is source, second is dispersing medium, a dispersing material, third one is detector. There are three basic components, you can say, in the analysis of spectroscopy. First is source. Source could be of visible light, could be of infrared radiation, could be of any range of electromagnetic radiations. And dispersing material is also any material of which we want to get the information about. So this material is of prime concern. Whatever material we want to investigate, we can put that material at this place. And detector is a simple screen from where we analyze the spectra. So this is the basic component for spectrometer. Now there are types of spectroscopy. So now I think I should erase this. Now we will see the types of spectroscopy. Types of spectroscopy. So there are primarily two types of spectroscopy. First one is absorption spectroscopy. Absorption spectroscopy. Second one is emission spectroscopy. In case of absorption spectroscopy, what happens? Let us elaborate this. Absorption spectroscopy. So in case of absorption spectroscopy, we have a certain element and we irradiate this element with a source of radiation. So this is the source of radiation. These are the radiations. Then what happens? Suppose these radiation contains four different wavelengths, lambda 1, lambda 2, lambda 3 and lambda 4, and this element contains certain atoms and molecules. Now in case of absorption spectroscopy, this element absorbs some wavelengths from this incident radiation. Let's say lambda 2 and lambda 3 are absorbed by this substance. Now what we will find here in the spectra, what we will notice? In spectra we will find lambda 2 and lambda 3 are missing. Lambda 2 and lambda 3 missing. It means we can easily, by studying this spectra, we can find lambda 2 and lambda 3 are missing. So this gives the information that this substance absorbs these types of radiations. So in this manner the absorption spectroscopy helps. In case of emission spectroscopy, what happens? We have a certain element and again we irradiate this element with certain radiations. Again we have lambda 1, lambda 2, lambda 3 and lambda 4. Then what happens? The atoms and molecules of this element absorb this radiation. In case of emission spectroscopy, and this substance absorbs some radiations, and after absorbing, what happens? The electrons goes to the excited state from ground state, and they get as much energy and go to the excited state. And after going to the excited state, as you know that the time period of excited state is very small, so they will finally come back to the ground state. So in this process of coming back to the ground state, they will emit certain radiations, and these radiations are recorded on a detector, and by analyzing this spectra we can find that these radiations are emitted by this substance. So this is the emission spectroscopy. So now I think this is clear. Absorption spectroscopy and emission spectroscopy, two types of spectroscopy. Now we will see the nature of dispersing medium. Dispersing medium. So there are nature of dispersing medium. Nature of dispersing medium. So you know that what happens when a prism is put in front of sun. So you know that we get a spectrum of 7 colors. So this is the one method of resolving a single light into its corresponding wavelengths. There is another method too. So let us first try it, then we will explain. So nature of dispersing medium. There are two types by which we can disperse. First by refraction and second by diffraction. So in case of refraction, what we will do? Let us first discuss this refraction. Nature of dispersing medium. Dispersing medium means suppose here is the source of radiations and here is our material, or this is the dispersing medium. This is the medium. This is dispersing medium and here is a detector. So this dispersing medium is in case of refraction. By refraction. So methods of this by refraction. By refraction what we will do? Suppose in front of sun we put prism. So by prism what happens? Sun, white light. So white light incident at any angle, suppose. So what happens? This light breaks into its components. So this single radiation after passing through this prism splits into 7 colors. 7 colors, you are familiar with it. So this single radiation after passing through prism is splits into 7 colors. So this is one method. So this is also a spectra. So by analyzing this spectra, by analyzing these 7 colors, we can say that white light is composed of 7 colors. So the term spectra was very first introduced by Sir Isaac Newton in about 1666. Sir Newton first observed this spectra of white light, and with the help of this spectra we can get the information about white light. Okay, after that second method we have diffraction. So by diffraction what we can do, we didn't use a source directly. What we do in case is simply first we will put a narrow opening in front of the source, and from this source the light enters only through this narrow opening. Means light enters in the form of a beam or a ray, single beam, narrow source, through it enters. So this is the in case of diffraction. So what are the advantages of these two types of diffraction? These two types of dispersing medium. So one by one we will see. So in case of refraction, we have intensity is very high, but the resolution is poor. And in case of diffraction, we have intensity is low, but resolution is high. intensity very high, it means the intensity very high, resolution is poor. So this means if you have noticed, intensity of spectra is high, but the resolution is poor in case of spectra. So let us understand. You know that when you put a scale in front of sun, then you notice a spectrum of 7 colors. You usually notice this. So what we can say that in case of spectra, the 7 colors are present, but you can't identify which color ends here and next color starts. Means there are submerged the Vibgyor, you know that the Vibgyor's sequence of this spectra. In this color, violet and indigo, these are very nearly connected to each other. There is no resolution in between these colors. There is a whole continuous range of this radiation. Or you can see the rainbow. In case of rainbow, you can't easily find which color ends and next color starts. So there is a poor resolution. Yet intensity is high. We can easily see all the colors, but we can't identify from where this color starts. There is a poor resolution in case of refraction. So this is the advantage and this is the disadvantage. Resolution is poor. So in case of diffraction, the intensity is low, but the resolution is high. If you ever go to the laboratory of physics and you do the experiment of diffraction grating, then in spectrometer we find easily the colors red, yellow. There are separate bands, like there is well resolved lines, means the resolution is high. So if we use this technique for dispersing the radiations into its constituent wavelengths, then we will find the high resolution, but intensity is quite much poor in comparison to refraction. And in case of refraction, the resolution is poor but intensity is high. So these are the two types by which we can analyze the spectrum. We can get the spectrum. So next we will see the unit of spectrum, unit of spectral lines. How we will measure, in which unit we will get these spectral lines. So let us throw light on this. Next we will see the units. So you know that lambda wavelength, the spectral lines, the spectra. If we take lambda as the unit of measurement or analysis of spectral lines, units, or you can say that analysis of spectral lines. So if we take lambda as the unit, then what drawbacks of this lambda has? You know that lambda is the wavelength, and you also know that lambda varies when medium changes. So it means if we fix lambda as our parameter, as our unit for the spectral lines analysis, then it is not our best choice because it alters when medium changes. So this is discarded. So lambda, we can't take lambda as the units of measurement of spectral lines. So what next unit we have in terms of waves? Next we have frequency. So if we take frequency, so you know that frequency doesn't changes on changing the medium. Why? The next question you should ask, if lambda changes on changing the mediums, then frequency should also change, because frequency and lambda are dependent on each other. How? Frequency and lambda. What is the relation between frequency and wavelength? Velocity. You know that velocity is equals to frequency into wavelength. This means frequency frequency, we can say that frequency is equals to velocity or wavelength. Means wavelength is frequency is dependent on wavelength. If wavelength changes, then frequency should also change. But frequency does not change on changing the medium. Then this question arises, why frequency does not changes? So you know that if suppose from one medium to another medium lambda increases twice, suppose lambda increases twice, then what? Then velocity will also increase twice. You know, frequency is the ratio of velocity and wavelength. So if lambda increases, then velocity will also increase in the proportion of lambda. So if wavelength becomes twice, velocity also becomes twice. The ratio is going to same. So in this manner, frequency remains the same. So frequency is the parameter which doesn't change with the medium. So we can take frequency as the limit, we can take frequency as the unit, but frequency is not taken as a unit. So what are the drawbacks of taking frequency as a unit? So let us see. So what are the disadvantages of taking frequency as the unit? So you know that frequency, we can take the short notation. C is equals to nu lambda in vacuum, and nu is the nu dash. Today onwards we will take nu dash as the frequency. C is the that speed of light, lambda vacuum, wavelength of radiation in vacuum. So this is the relation between frequency and this. So now consider, suppose we have a radiation of range in the visible region. So consider lambda is in the range of 4000 angstrom to 8000 angstrom. So consider any arbitrary lambda. Let us take 6000 angstrom lambda. Now we will find the frequency corresponding to this wavelength. So frequency corresponding to this wavelength will be 3 into 10 to the power 8 over 6000 into 10 to the power minus 10. So this equivalently equals to come in the power of 10 to the power 14. Equivalently, this after solving this you will get this is nearly equal to this number. So this number is very large number. This number is very large number. So due to which we can't take frequency as our scale. So this is the drawback. What were the drawback with lambda? Lambda changes with changing in medium, and frequency has a very large number. So frequency and lambda both are not suitable for making the scale for spectral lines. So what was done at that time, if we take the reciprocal of this frequency, then this number will obviously be a small number. So this number will taken at that time. So this new term, this is the so what we will see, the frequency is very large number and wavelength changes on changing the medium. So what was done at that time, consider we divide this term with speed of light. If we divide this with speed of light, then this number will be a measurable, not very large, not very small. It's a measurable quantity came. So that's why this term is equals to, you also know that C is equals to nu lambda in vacuum, lambda vacuum, and nu dash is the frequency over C is equals to 1 by lambda vacuum. So this term is equals to 1 by lambda vacuum. So we can write 1 by lambda vacuum is equals to nu dash over C. So now this new term named as wave number. This is named as wave number, and this is taken as the unit. We will represent throughout this lecture. We will represent this term with nu and frequency with nu dash. So we will represent this term with nu. This is wave number, and it comes equals to frequency over speed of light. And we can easily calculate this by finding the wavelength. If we don't know the wavelength in vacuum, then what we will do? We know that lambda vacuum over lambda medium is equals to the refractive index of that medium. So in order to finding lambda vacuum, we will take this term at this place. So we find wave number is equals to 1 by refractive index of the medium into wavelength of radiation in that medium. So this will give us the scale. This scale is centimeter inverse or meter inverse. So this is the scale for analysis of spectral lines in case of spectroscopy. So wave number is a suitable unit. So this, you know that we have, this is a suitable unit, and throughout this study we will take the wave number as a unit for measurement of spectral lines. So this was the very basic introduction to spectroscopic lecture. Next, in the next lecture we will see the very simplest spectra of hydrogen atom, and after that we will see the various theories to explain the spectra of hydrogen atom. So stay tuned. Thanks for watching.